Okay, we're going to look at chapter 4.3 now. The topic is causation. It's a pretty straightforward set of slides here, but you need to take notes on it because we're getting into the section here that's all about terminology. Okay, so first is the beware the post hoc fallacy, and this is something we've talked about again and again, and people will continue to make the mistake. Post hoc ergo propter hoc. The idea is that just because two things are related, therefore one causes the other. Okay, so that's the fallacy here. Just because two things are related doesn't mean that one caused the other. So to avoid falling for the post hoc fallacy, assuming that an observed correlation is due to causation, you just got to be really careful. Here's a graph on the right here of this is from Vengaza, which is the flying spaghetti monster. If you're not familiar with it, it's a pretty amusing website. And it shows the relationship, a strong correlation, r squared 0.8082, which means that 80.82% of the variability in global average temperature can be explained by the relationship between the global average temperature and the number of pirates over time. Okay, so obviously it's silly, but the idea is that we can't establish causation after the fact. That is, we can't go and hunting for two pieces of data and say, here, these two things are related, therefore they must be causal relationships. The only way we can actually show causation is if we have designed an experiment, okay, that has intentionally altered something in order to see what the outcome is. Okay, so we can't just take two pieces of data and put them together and say, oh, there must be a causal relationship. Okay, so there's three ways we talk about causation. The first is a simple X causes Y. Okay, so that's a possibility, but again, this can only be established through well-designed experiments. The other one is a common response. So we have a relationship between two things, and there's actually a third response out. There's something else out there that's causing both of them to change. Now with the pirates and global warming, you might say that the third variable is time. Okay, as time has gone on, it's increased both, or perhaps it's some kind of industrialization. But in any case, a common response is one thing that affects the outcome of both. Okay, and that you see them both rising in response. And then the third one is confounding. Okay, confounding is where X causes Y, but there's a third variable, or X may have a relationship with Y, but really there might be a third variable that's actually one causing Y. Okay, and the issue is you cannot tell in the context of your data which one is actually causing Y. So to review, we have causation, direct causation. One is common response. Okay, one thing causes other two things to happen, and you're seeing the relationship between the outcomes. And confounding, common response is sometimes called lurking variables. And confounding is where I think X might cause Y, but on the other hand, it might be something else that's actually causing Y. Okay, so and we'll look at some examples in a second here. Okay, the only way to really show causation, okay, it's really hard to establish. I mean, it took years and years for the scientific community to really feel comfortable with the causal relationship between lung cancer and lung cancer and smoking. Okay, we kind of had this sense that was there's a causal relationship, but to actually really prove it was very hard. So the best evidence for causation comes when you fix everything else and you move one variable in order to see what happens to the only other variable you haven't fixed. Okay, even when you have causal relationships, it's almost never a complete understanding. It's almost never a complete explanation. Okay, and the other thing to remember is that just because you're able to see a relationship between two variables and you're able to establish causation doesn't mean that's going to hold in another experiment or in another context. Okay, so the common response again. So the you see a relationship between two things, but really what's happening is there's a third thing causing both to vary. Okay, so the Presbyterian ministers and barrels of rum. So there's a well-established relationship between the number of Presbyterian ministers in New England and barrels of rum sold in Cuba. Okay, or you know, and really there might be a very strong relationship there, but it's not that the Presbyterian ministers are causing rum sales to go up. There's a third variable out there, and there might be many variables that are causing this, that's causing the amount of rum sold to go up as long as with the Presbyterian ministers. It could be something as simple as population growth. Okay, the more ministers out there reflects the fact that there's more people out there. Okay, and more people means everything is going to be sold in higher quantities, including rum. Okay, so it's really population growth that's impacting the number of Presbyterian ministers and the amount of rum sales. Confounding is a little bit little stranger. Confounding comes up in the case of experiments. Okay, where you're trying to show that X causes Y, but at the end of the day, it might be that it was the Z that caused Y. Okay, and you can't seem to distinguish which one it was. Okay, so it's when you're trying to establish causation when a confounding variable comes up. It's a little bit like if you're trying to show that taking a particular drug causes your blood pressure to decrease. Okay, so you find there's a relationship between a drug that you're taking and the and blood pressure. But at the end of the day, you look back at your data and you realize that everyone in your study was exercising and eating well and all those sorts of things. So at the end of the day, you look back and you say, well, I can't really tell if their blood pressure went down because of the drugs I was giving them, or if it's because they were being healthier. They were eating healthier. They were exercising more. So which frankly I don't know if that would make any difference. But the idea is that I'm trying to show that X causes Y, and yet because I forgot to look at another variable out there, I can't tell if maybe it was Z that caused Y. Okay. Okay. So we're going to do a couple exercises here, and then or look through a couple and explain them, and then we'll call it. Okay. So here's exercise 4.41. There's a high positive correlation between nations with many TV sets and that have higher life expectancies. If we lengthen the life of people in Rwanda by shipping them TVs, will that work? Okay. And no, it won't. Right. There's a lurking variable out there, and that is income. Right. Countries that have a higher GDP typically have better resources to healthcare and things like that, as well as more access to wealth. Okay, there's a third variable out there that's causing both those things to increase. Okay, people who use artificial sweeteners in place of sugar tend to be heavier than people who use sugar. Does artificial sweetener cause weight gain? Well, maybe, right? This might be a case of a confounding variable. Maybe it could be that putting artificial sweetener into a drink causes weight gain. We don't know. Okay, but we didn't necessarily control for what else was happening. There's a third variable out there, and my variable that I would see here is that people who are using artificial sweeteners are people who are concerned about weight gain in the first place. People who are maybe struggling with weight gain. Okay, this is just a hypothetical here. But again, there's a third variable out there that may be causing them to use artificial sweeteners and causing their weights to increase or decrease, but more likely it's that instead of looking at the fact that it was sweeteners causing weight gain, there might be something else out there that's common to everybody in the study that's causing the weight gain. So this might be the case of a confounding variable. Okay, and finally, women who work in the production of computer chips have abnormally high numbers of miscarriages. The union claimed chemicals cause miscarriages. Another explanation may be the fact that workers spend a lot of time on their feet. Okay. Pretty straightforward here, right? We look at it and say, well, the union says chemicals cause miscarriages. That's very possible, right? But there's another explanation that maybe we didn't control for and we saw that. That's a confounding variable, okay? Being on your feet might cause the miscarriages, and so might the chemicals. You can't distinguish necessarily which one it is. That's confounding. As distinguished from lurking or common response, where being on your feet doesn't cause chemicals to do anything and doesn't cause miscarriages necessarily. It's that we can't tell if the chemicals caused it or if being on your feet caused it. Okay, so it's a quick video for today.